So before we move into platelets or thrombocytes that are critical in the clotting of blood or coagulation of blood or hemostasis, the stoppage of blood flow from the cardiovascular system, please go back to basophils and put in that they also secrete heparin, which is an anticoagulant. So on to thrombocytes. So thrombocytes are actually, as you can see in this picture here, really small fragments of megakaryocytes. And the megakaryocyte is the derivative of the common stem cell of red, white, and platelet cells, the hemocytoblast. And it goes through a process that takes about 4 to 5 days. And at the very end, you have this multi-lobed or multi-nucleate megakaryocyte. That's a big cell or big nucleus cell. And from it, we get these platelets that are actually fragments that simply contain granules of chemicals essential in the clotting process. So here's a short list of some of the chemicals that are contained in the granules of a platelet. So when platelets aggregate after vasoconstriction of a damaged vessel or a damaged body part, they release these granules. Serotonin is a vasoconstrictor that aids in constriction of the smooth muscle of the vessel walls. Calcium, which is part of the third phase of hemostasis, the coagulation cascade, and you can see its play here in several parts and here. It also increases constriction of the smooth muscle in the vessel walls. Multiple enzymes such as dehydrogenases and lactase. ADP, which together with thromboxane A2 and serotonin causes platelets to aggregate at the site of injury. PDGF, platelet-derived growth factor, which is a chemotactic agent for platelet aggregation, and von Willebrand factor, which when released acts as a ligand on the damaged epithelial cells or endothelial cells to attract more platelets. Normally, if clotting isn't necessary or there aren't damaged tissues or damaged vessels, the endothelial cells of the vessels release nitric oxide, NO, and prostacyclins. So NO and prostacyclin are released from healthy endothelial cells, the cells that line the blood vessels, and are a signal that the vessel should keep expanding or involved in vasodilation and not get involved in the clotting process. Now, platelets, unlike red blood cells, have a fairly short lifespan. It's only about 10 days, and their stimulation or their production is stimulated by thrombopoietin. Thrombo being clot-forming cells, poietin being formation of those cells. And again, just like red blood cells, they derive from the hemocytoblast. So now we'll talk about the process of hemostasis, which is the process of stopping blood loss from the cardiovascular system. So stopping blood loss from damaged vessels and tissues or from damaged vessels themselves. Now the first phase of that is vascular spasm. And in vascular spasm or vasoconstriction, the blood vessel closes down, the smooth muscle constricts, slowing blood flow to the area. Platelet plug formation involves the aggregation or coming together of multiple platelets to that area of injury. Third is coagulation, which is the permanent fix or chemical fix, cellular fix to that area of injury. So now let's talk about each of these steps with some more detail. So in this animation, we're about to see injured endothelium, that is, an injured blood vessel within a tissue or an injured blood vessel by itself. Now that injury damages these endothelial cells, simple squamous cells that line the lumen, the opening of the blood vessel. Those cells stop producing nitric oxide, and they stop producing prostacyclin. We also see that because of that, there are collagen fibers exposed, tissue fibers exposed, or tissue factors rather exposed, and the endothelial cells will stop producing heparin, which inactivates thrombin, and thrombomodulin, which activates protein C and thus inactivates some of the clotting factors. In addition, those damaged vessels will also release pain reflexes that include the release of ADP, bradykinins. So in the second stage of hemostasis, which is platelet plug formation, we see here that the damaged endothelium area has attracted some platelets. Those platelets will also bind von Willebrand factor, which acts somewhat like tentacles or glue that attracts more and more platelets to that activated area. These activated platelets aggregate and granulate, which means that they release their chemicals we talked about previously and cause further vasoconstriction. And the release of those granules also includes the release of von Willebrand factor that will attract even more platelets, ADP, serotonin, and thromboxane A2 that will again increase the adhesion of more and more platelets. The third stage of hemostasis is the coagulation pathway, the actual chemical clotting of blood, which produces a scab on the outside or a clot inside a vessel or a tissue, and ultimately regeneration and fixing of the vessel's structures, the smooth muscle, the endothelium, and the basement membrane. Now, if we go back to the overview of these processes, we can see that if you liken this to, say, fixing a pipe that's burst in a home, the first step, vascular spasm, would be you turning off the water. The second step would be, say, putting in a temporary plug to the pipe, and the third step would be the soldering or the replacement of that particular piece of pipe. Now, coagulation itself occurs with three pieces or three stages. The first stage is using either the intrinsic pathway or the extrinsic pathway to form prothrombin. That's a pre-thrombin. The second stage is the activation of prothrombin to thrombin, and the third being the formation of fibrinogen into a series of cross-linked mesh fibrin fibers that contain the platelets, and ultimately those fibrin fibers will contract, will squeeze out the plasma so that what you're left with is a fairly solid mound, scab, or clot inside the vessel. Question 13. Just like erythropoiesis, leukopoiesis originates with a hemocytoblast. So, name the two stem cell lines that originate from the hemocytoblast under the direction of colony-stimulating factor and interleukins to create all 5 types of leukocytes. Question 14. What is a megakaryocyte? Question 15. We know that mature platelets are not full-fledged cells. Explain what a mature platelet is and the functions of chemicals in its granules, serotonin, calcium ions, ADP, PDGF, thromboxane A2, von Willebrand factor, and the general function of enzymes. 16. There are several chemicals that prohibit spontaneous clotting, including nitric oxide, prostacyclins, von Willebrand factor, heparin, and thrombomodulin. Explain the functions of those chemicals in terms of how they prevent spontaneous clotting from occurring.